Okay, so in this question we're dealing with impulse, and it says, in the figure, what value of Fmax gives an impulse of 6 newtons times seconds? So let's talk about impulse then, since that's what they're really getting at here. In this graph, we have in the y-axis here, we have force. And in the x-axis, of course, we have time. So what we're talking about here is we're talking about a force applied over a given amount of time, which we call impulse. So they want to know what the total amount of impulse is, but most of the time whenever we're talking about impulse, we're talking about not the maximum force, but we are talking about the average force times the time. So how do we find the maximum force? Well, J can also be equal, instead of just the average force, it can also be equal to the area under the curve. So in this case we have a triangle, so all this shaded jazz under there, that is going to be the area that we're talking about, which is the same as if we took the average force and times it by the time. So we have a triangle like we were talking about, so let's rewrite this. So we have J, or our impulse, is equal to the area of a triangle, which we know is 1/2 times the base times the height. So what is our base? Well, oh, and also they give us J right here with 6 newtons per second, or times second, I mean. So let's plug that in too. So we get 6 newtons times seconds equals 1/2 times the base, which is 8 milliseconds, times the height, which in this case is Fmax. So if we take 6 divided by 1/2 times 8 milliseconds, we get Fmax. And that will be our answer. Now, some of you probably did this, and you plugged in all the numbers just like this, and you put it into Mastering Chemistry, and it gave you the purple box of death, and you're really mad because you know you got the question right. So what they did is they were being sneaky little buggers, and they put in milliseconds instead of normal seconds. And in this equation, we have to have SI units of seconds. So that obviously changes things. So now we have 6 divided by 1/2 times milliseconds, and so there's 1,000 milliseconds in a second. So we get 0.008 seconds equals Fmax. Now when you do this, we get, well, I guess I had to pull up my calculator, and let's just do it real quick. So 6 divided by parentheses 0.5 times 0.008 close parentheses, and that gives, oh whoops, why did I say 0.5? I meant 0.8. All right, so that gives us 1500, and we're talking about a force, so that is 1500 newtons, and that is the answer.